about this, I'll talk about this. Now we're in the next one, which is mass-mass relationship when it comes to stoichiometry, or we can call it mass-mass stoichiometry or mass-mass whatever. So basically what it entails is that a mass of a particular compound will be given to you, while the mass of another compound will be required. So it means they are giving you mass, they are asking for mass. That's what's called mass-mass relationship. We also have mass volume. They are giving you mass, so they are giving you volume, they are asking you for mass. When we get there, we'll cross that bridge. So when it comes to mass-mass relationship, there are two methods to use, but I will actually suggest the shortest one, which is what I'm going to teach now. You get? Now there are two methods. Number one, either you compare with masses, or two, you compare with the number of moles. Please take note. Two methods. One, either you compare with the masses, right? Two, or you compare with the number of moles. You get? So I'm going to show you the two methods. I'm going to show you how they work. Please take note that when it comes to mass-mass relationship or mass-mass stoichiometry, a balanced chemical reaction is required. So I believe by now you should know how to balance a chemical reaction, right? Please, if you don't, please just search on YouTube. You can go to my friend's channel, 𝗁𝗂𝗏, Chemistry with 𝗁𝗂𝗏. Go and check. I think he has done some videos on that. So you can go and watch that on how to balance chemical reactions. So that will not really be an hindrance to you, in case you don't know it. Alright, so let's move. Look at this question. So I'm going to start with the question. Let's go back. Now we are starting the stoichiometry. 2CO gas plus O2 gas combines to give 2CO2, which is a gas. They said from the reaction above, the mass of oxygen used in the reaction of 24 grams of CO is that, given that C is 12 and O is what? 16. They are going to have to split the board to solve. You get, see, this is a typical mass-mass problem. How do we know? Remember, I said the mass-mass stoichiometry. What it entails is that they are giving you the mass of a particular compound. They are asking you for the mass of the other one. Let's do that. Now, they give us 24 grams of this is the mass of 𝗁𝗵𝗁 or 𝗁𝗵𝗁𝗀, and they are asking us to look for the mass of oxygen rather. So you see, they are giving us mass, asking us to look for mass. And this is 𝗁𝗵𝗁𝗀. So they are asking us what mass of oxygen actually reacted with this guy to form 𝗁𝗁𝗁𝗀. Very, very easy. Very easy. So I'm going to solve with these two methods. Number one, I said method one, compare with masses. So when we talk about stoichiometry, what we just do basically is that we do comparison. We compare. You get, but the compare is in different categories. So the first one we want to compare, you will actually put the molar mass or the base atomic mass of the compounds in particular in both. Because typically if you are comparing, you compare between two quantities, between two species, between two chemical reactants or products, or between two chemical reactant species. You don't compare more than 3. So just like saying, if I give you 15 naira today and you told me thank you, if I give you 100 naira tomorrow, you will tell me thank you 2 times. I don't know if you get. That's how we compare, because that is what comparison is. So we compare two stuffs when it comes to stoichiometry. So we compare what we are given to what we are looking for. For instance, look at now, they see the reaction of the mass of oxygen. So we are looking for the mass of oxygen, and they give us the mass of 𝗁𝗁𝗁𝗁. So it means we are not concerned with this guy. What we are concerned is this guy and this guy. We are comparing them. So the first thing that you want to compare, okay, this one is method 1. Step 1, compare their molar mass. You get, compare their molar masses. You get, since you are comparing these two guys, look at it. Now, this is 𝗁𝗁𝗁𝗁, this is oxygen. So what we do is that we say, what is the molar mass of 𝗁𝗁𝗁𝗁? Is just, can you see this board? Let me use it to solve it briefly. 𝗁𝗁𝗁𝗁 is C plus O. C is what? 12, oxygen 16. This is what? 28. So it means we now say 28 gram per mole of carbon monoxide gave us oxygen is 32, oxygen gas, because 16 times this 2 give us 16 gram of. Let me put the units. 28 gram per mole of carbon monoxide gave us 16 gram per mole, or we added 16 gram per mole of oxygen. So this is the first comparison. So when we are comparing with masses, the first thing we want to do is I want to compare their molar masses first. You get, so we are comparing, because why are we using this? Why are we leaving this one out of the game? Because they say this is 24 grams of this guy, and we are looking for the mass of this guy, so we are concerned with these two guys. So even though there are 20 compounds in this reaction, it does not concern us. You get, we are concerned with just the graph. So now we are going to compare their molar mass. We're going to say 28 grams per mole of this guy will give 16 grams per mole of this guy, right? Now we're not. This is actually correct. You see, anything that stands in between or before the particular compound, you use to multiply the molar mass. You get what these guys are making us. You use to multiply what? The molar mass. You use to multiply the molar mass. Do you get? So let me continue. Let me tell them to be quiet. Right, so I was saying something. I said now, when you are comparing their molar masses, please take note of this. Write it in your book. When you are comparing their molar mass, multiply it with the number of molecules. Like if there is 2 here, this will now be 2 times 28. If there is 3, it will be 3. If you have 5 here, we have 5 times 16. Please, that's only when you are comparing what their molar mass. Do you understand? So it means if we are comparing and we have 12 here, this will be 12 times 16. If you have 18 here, it will be 18 times this guy. So that's what we have on the board. So we have 2 times 28 grams per mole of this guy. We have 16 grams per mole of this guy. You get it? So let's do 2 times 28. That's 42. Abina. Sorry, 50, is it 50? 56 rather. What am I even doing? Please let me calculate. 2 times 28. 56 now. 56. So it means 56 grams per mole of this guy. Let's use the English because it's the same. We add to this of oxygen. Good. Now we have not gotten an answer. This is just the first step. You get. Then step 2. Compare the masses. And these masses we are talking about the masses from the question. Remember they say 24 grams of this guy. CO. So we are looking for oxygen. This way we will not get oxygen. Because see where we see where you are in the comparison now. We have be able to derive that 56 grams per mole of this guy, we are with 16 grams per mole of oxygen. Now let's compare their masses. So they give us that this is 24 grams of this guy, so we now have 24. We give what? S gram of what? So 24 grams of CO will react with S gram of oxygen gas. You get, so at this point, that's where we are looking for what? Oxygen. Let me come again. Now the question says this is the equation, right? Then I say from the reaction above, the mass of oxygen used in the reaction of 24 grams of CO is what? So I look for the mass of oxygen. Now I said this method of comparing with the masses, because if you say everything has to do with mass, molar mass, you get the first step is for you to compare what? Their molar masses. Compare their molar masses. So we have this is 28, we calculated it just now. 28, you get 28 is the molar mass. Remember, we are comparing their molar masses. So I made a mistake. This is supposed to be 32 grams of oxygen. Oxygen gas. Thank God I started again. This is O is 16 times 232. You get? Alright, so that does it. So why do we add this 2? Because 2 standing for this guy. So 2 times 28 is 56 grams of this guy. Is what? Reacting with what? 22 grams for oxygen. And now that's the first step. The second step, compare what? The masses. Compare the masses. What do I mean by compare the masses? Now they give us the mass of CO as 24. We are looking for the mass of oxygen. This one will not get the mass of oxygen. You get, so we say, please take note, in this comparing the masses, whatever that is standing before it, like if there is 5 here, don't multiply. I don't want to do 2 times this here again here. You only use the stuff that is standing before it when you are comparing their molar mass. You grab. So this is the stuff we now compare. So let's do this here because this zone is kind of my ring light region. You get, so if you are right here, you may not see it. So let's bring it here. So remember that we stated that 56 grams per mole of CO reacted with what? 32 grams per mole of oxygen. Then 24 grams of this guy react with S grams of oxygen. Why? Because I don't know the mass of oxygen. So what we are going to multiply? This is 56 times S. That's 56 S equals to what? 24 times 32. 24 times 32. 24 times 32. We have 768. So X equals to 768 all over 6. We have 768 divided by what? 56. So we have X equals to 13.7 grams of oxygen gas. So the mass of oxygen gas that was reacted is what? 30.7 grams. It's as easy as that. Do you understand? So let's take the next example. The next work example. Okay. Just hold on. Okay. I've got another. Okay, let me solve for the other method. Now this method is for what? From comparing masses. You get. There's also a method that we can use that's comparing the number of moles. But that one is actually the long method. So I advise that if you have observed the question, you have seen that the question is a mass kind of problem. Use this comparing the masses method. You get. But let me just teach you the number of mole methods. The same question. I'm only going to write how I solved it. Right, I'm going to write how I solved it. Okay. Alright, so let's go. Number of moles. Now the thing is that we want to calculate, want to compare the number of moles from the question. Now this 2CO is the same thing as 2 moles of CO. This O like this is the same thing as 1 mole of oxygen gas. So if there's still here, it's now until we get the stuff now. So that's one thing you should know. So now we can see that from the equation of step 1 we are comparing what? Please take note, we are comparing the number of moles. You get, we are comparing number of moles, which is N. You get. So I can say here 2 moles of CO reacted with what? 1 mole of oxygen gas. You agree with me? It's from the equation, right? Now we'll now have to look for with this value of mass that I was given. Do you know that we can look for molar mass? Remember that number of moles equals to mass over molar mass. So I want to look for the number of moles of this guy that was reacted. Number of what's this 24 that is the mass, right? All over what is the molar mass of CO? We calculated that as 28 just now. Sorry, I know you cannot see me. Don't worry, just looking at the board. So 24 divided by 28 is 0.857 moles. So we'll now say, because this is the number of moles of the CO2 that now reacted, CO that now reacted, right? So remember we are comparing number of moles, so it means we are still going to compare with number of moles again. So since I've gotten this number of moles from this, I don't know if you are confused. It's easy. Number of moles now. Now this first number of moles is from the equation. The second one will be from the stuff that is given in the question. So 24 grams of CO is, you can use to get the number of moles of CO because this is the mass, and CO, the molar mass is 28. So we can now say 24 divided, we have 0.857. So we now say 0.857 moles of CO will react with S mole of oxygen, right? Let's cross multiply. You now have 2x, right? 2x equals to 0.857 all over 2. X equals to 0.8 divided by 2. We now have 0.429 moles of oxygen. Is it the final answer? No. This is just the number of moles of oxygen that will be produced. You get. And remember, number of moles is equal to mass over molar mass. So it means if this is the number of moles of oxygen, we cannot get the mass because they ask for the mass of oxygen. We cannot get it now. Remember the oxygen gas, the molar mass is 32, right? And this is 0 point. We are getting the number of moles as what? So remember, if you go to multiply, we get that the mass of oxygen is equal to the number of moles times the molar mass. The mass of oxygen now, what is the number of moles? 0.429. What is the molar mass? times 32, right? See, times 32. So we now see have 13.7 grams of oxygen. So we can see now that the mass of oxygen that was formed is 20.7 grams. I recommend that you master this method. You get, because this method, even when we come to other parts of stoichiometry, like comparing volumes with mass, concentration with mass, this formula is one that is going to help you. This one has to be comparing number of moles. So I think I'll be sticking with this one. I'll actually solve a next question. That question I'm going to use both methods again. So after that question, all my other methods I'm using number of methods, so as you get used to it. So when we enter other parts of stoichiometry, like stoichiometry of solutions and everything, it will not be hard for you. Do you understand? But you can actually use that other method anytime. But I think we'll start doing this one. So let's go for another. Let's take another question and use both methods to also solve. You get, that will be example 2. So I'll use both methods to also solve and explain. So I think from that one you should be able to catch what the method is all about. Right? Okay, so let's go. Now, the worst thing they can do to you is not even the worst, it's just a normal stuff you should know. For you to be very, very good at stoichiometry, you must know how to actually derive, you must know how to derive equations from the equation. That's why you must get exposed to so many kind of reactions. You must get exposed to many reactions when it comes to chemistry. So that when a particular question is being asked, because most times they will not give you the formula, they will not give you the equation. You have to crack the equation all by yourself. And that's why, and most of them, there are common reactions like neutralization reactions, preparation of some compounds, you get test of some compound. Those are the kind of formulas you'll be seeing. And most, they will not give it to you. That's why they are jam. Because they are procedure, they will not give it to you. So you have to be a chemist student, you have to be able to like know, okay, when this guy react with this guy, from studying, when this guy react with this guy, this should be formed, you get. So let's go to example 2. Example 2, the solution using the two methods, right? Now they said this one I will have to look for the equation myself. 2.5 grams of ACl was formed from the direct combination of hydrogen and chlorine. Okay, hydrogen and chlorine under standard conditions. The mass of chlorine that we added is dash. Give it that H is what? 1 and chlorine is 35.5. Very, very easy question. Now the first thing is to get the equation, and the simple equation is this: H2 plus C2 equals to 2ACl. Let's just say that's the hydrogen chloride that was formed gas. And the equation is balanced. How do you know the equation is balanced? We have 2 hydrogen here, we have 2 here, that's 2 times H. We have 2 chlorine here, we have 2, so it's balanced. So they said now that 2.5 grams of ACl was formed. We are looking for what? The mass of chlorine. So it's still mass relationship. Why? The mass of ACl was given, and now they want us to look for the mass of what? Chlorine. So let's use the first method. Comparing masses method. Remember, when it comes to comparing masses method, step 1, compare the molar masses. Now remember, what you have business with now is chlorine and EOT, because those are the two stuff that I mentioned. How it has 200 of ACl and the reason of the mass of chlorine. And now without being able to hydrogen, forget the fact that it's in the equation. So the first one to compare their masses, remember, so that we can see now the mass of chlorine is at 5.5. Chlorine gas like this is 35.5 times 2 is 1 gram per kilogram. So we'll now compare. Because we are comparing these two. You can see now 71 gram per mole of chlorine 𝗵 reacted with what? 2 HCl. Now we are going to look for, let's put the 2 here because this, remember I said when you compare molar mass, only when you compare molar mass, use the 2 here to multiply the molar mass. So HCl is the same thing as H plus Cl. H is 1, Cl is 35.5. So HCl is 36.5 𝗵. So we'll now put this guy here. Remember we are comparing what? Molar mass. Let me come again. 71 gram of this guy reacted with what? 36.5. But why we put in 2? Because there's 2 here. Remember, as if you had 3 here, we would have said 3 times 71. Sure you get. So that's first step. Step 2 is to compare the masses. Compare their masses, right? Now, they gave us the mass of this guy. So we don't know the mass of HCl. So we'll now say S gram of chlorine gas will now react with what? Because there's 2.5, yet 2.5 gram of HCl. So let's bring everything we have done here. Yes, because of this ring light that I said, so I cannot like you be able to see what I'm writing. Yes. So now let's bring the first part. 31 gram and more of this guy. It was 2 times 36.5. 2 times 10.6.5. That should be 73. So we have give us 73 dc of HCl. Then X gram of chlorine will give us what? 2.5. So just multiply. So we now have 71 times 2.5 plus 73x. So let's do 71 times 2.5. 31 times 2.5. That's 177.5 plus 73x. So if you divide by 73, so we now have that 2.43 equals to x. So that means the mass of chlorine, that is, what is it reacted now? 0.43 gram. You get 2.43 gram. That is just it. So you see now, that's for comparing the masses. I said let's go for comparing. Let's go for the other comparison. Let's compare with the number of moles. That's the method. You can learn both methods. But our agenda is we get used to the mole type of method because if you not wrong, that's why it's going to help you more when it comes to stoichiometry. Share your getting it now. So the number one method B, comparing the number of moles. This is the method I will be using. So since we are making this gas, just also do that 1 mole of chlorine reacted with what? 2 moles of HCl. Then the next thing, you now look for what is given. See 2.5 gram of this guy. You use that value to look for the number of moles of HCl. Number of moles equals to mass over molar mass. Remember that HCl, we calculated the molar mass as 36.5. So this is now simply as what? 2.5, which is the mass given, over 36.5, which is the molar mass of this guy. You get. So what we now have is 2.5 divided by 36.5. So you have 0.06. Okay. So you have 0.0685 moles. So you get that's the moles of what this guy. So when I say X moles, we are looking for the number of moles of chlorine now. So it means S moles of chlorine will react with what? 0.0685 moles of hydrogen. You get, let's come here, let's come at the mass. So remember, 1 react with 2, then X will react with what? 0.0685 plus multiply 1 times this guy, 0.0685 plus 2x divided by 2, you get, so this guy divided by 2, sorry, 0.085 divided by 2, you have 0.034 equals to x. So that means the number of moles of chlorine you get. But that's not what they have to look for. They have to look for the mass of chlorine. And remember, now number of moles equals to mass over molar mass. From here, if you multiply, you have the mass of chlorine equals to number of moles times molar mass of. Because we're talking about the chlorine here, you get the mass now. What's the number of moles? 0.034. What is the molar mass of chlorine? Chlorine is Cl2. That's 35.5 times 2, which is 71. 2 times 71. Abi? So that's the molar mass. We have times 71. We have 2.43 grams. So mass of chlorine is 2.43 grams. Very, very easy. So this is the method I want you to master. You see how simple it is now, right? That was it. Let's go for example 3. Let's see. Let's see if we have another example. Or another example again. Okay. That's just it too. Let me forge one question. We go help me man forging. Not gonna forge no existence. And this last one, I'm going to please you guys get used to the number of moles method. Though it's going to be long. The reason why I'm doing why it's kind of long to us now is because I'm just trying not to rush. You get it's very, very fast. If you get used to it, you'll be very, very, very fast. So let's go for example 3. So that we know we are doing mass relationship. So this we have to take now is practice questions. Example 3. If 25 grams of ACL neutralize NaOH, calculate the mass of water from very straightforward. A is equals to 1, O is equals to 16, so this is equals to 35, and A is equals to what? 23. Very, very, very easy. You see this question now, there was no equation. That's why you have to know that when ACL reacts with NaOH, this is what? A neutralization reaction. We now have sodium chloride plus H2. This is basic neutralization, formation of soda and water. Let's leave the state. I believe you know the state already. So if you can see everything now is balanced. So there's no anything there. You get so let's use this another case. So because all the other ones we have doing since we are used to have to you get this one without anything there. So let's leave it that way. So let's go. We are using number of moles comparison. Now what are we focusing on? ACL, because they give us mass of ACL and mass of ACL. I just don't know. See this thing now. Don't go and get confused and see what I'm looking for. Let's look at the mass of method that gives us mass of this guy. So let's use number of moles method. So what I'm comparing is this guy and this guy. So you can see 1 mole of what? ACL produce what? 1 mole of what? Water. That's the very, very first step from the balanced equation. Now the next 25 grams of ACL. Remember, number of moles of ACL equals to mass over what? Molar mass. This is what? 25 over what? 36.5. Remember, we have what we just now. ACL is H plus Cl. That's 1 plus 35.5. That's 36.5. You get. So let's go. 25 divided by 36.5 is 0.685. So it means number of moles equal to 0.685 of what? ACL. So it now means 0.685 moles of ACL. We produce how many mole? S mole of water. So you get. So you cross multiply. God, you really like let's do it. Let's do it here. So you see how easy this thing is. So 1 times X. So we have S mole of H2O, which we are looking for, is equal to what? 1 times this guy, 0.685 times 1. So it means they have this number of moles. That means the number of moles of this guy is what? 0.685. Is that what I'm looking for? No. Remember, number of moles equals to mass over molar mass. And if you multiply mass equals to number of moles times molar mass of what? Water. Because this is the number of moles of what? Water. Now water is H2O. You get which is H2 plus O. H is 1 times 2 plus 16, right? That's 18. That's 2 plus 16, 18. That means the molar mass of this guy is 18. So the mass of water is equals, what is the number of moles? 0.685. What is the number of moles times 18? Check it times 18, 12.33. So it means the mass of H2O that is formed is 12.33 gram. It is what it is. You get it is as easy as this, very easy. Let's see if you are going to have some. Let me see if I have work examples. Or should I say classworks rather? Please hold on. Okay. Please hold on. I should have questions here. I don't have. Just quickly, let me punch one again. I really forge anymore. Let me just do that sharp polish, and then we'll solve it very fast. Now let's give a complex one. What if we have H2SO4 plus 𝗁𝗲𝗃? Okay. Any equation can do it though. We now have what? Na2SO4 plus what? Water. Any equation. But this is not balanced. Yes. Yes. This we have a balanced equation. We have 2 here, 2 here, 4. If you have 2 here, that's 4. Oxygen 6. Oxygen 2 here is 6. Sodium 2. Yeah, it's balanced this way. You can see the balance equation from this reaction. Then let's say from the reaction, this ROS in this reaction are both. What is the mass of H2SO4 needed to completely neutralize 𝗁𝗲𝗃? You get mass question. Given that H is 1, S is 32, O is 16, sodium is 23. Very simple, right? Very simple. You get comparing the masses. Number 1, we are concerned with what they are looking for the mass of H2SO4, right? And it was the mass of. Sorry, completely neutralize 46 gram of 𝗁𝗲𝗃. Okay. So that's it. They gave us the mass of 𝗁𝗲𝗃, but looking for the mass of H2SO4. So just use the distance. So we can say 1 mole of what? H2SO4 reacted with what? 2 moles of 𝗁𝗲𝗃 from the balance equation. You get. So let's look for the moles of this thing now. So this thing mass over molar mass. What is the mass now for this? It doesn't put molar mass 23. This is what? Is it not 2? 2. So we say X moles of H2SO4 we have what? 2 moles. You get. So let's just multiply. So we have 1 times 2. 2 is equals to 2x. That's 2. So x is equals to 1. That is number of moles of H2SO4 is equals to 1. You get from the, if you do the mass. So now remember, number of moles equals to mass over molar mass. Mass of H2SO4 equals to number of moles times molar mass. Remember I said before that the molar mass of H2SO4 is 90. You can calculate for it. So the mass of H2SO4, what is the number of moles now? 1 times 98. So it means the mass equals to 98 grams. So that's it for mass problems. I believe you understand this. Now we'll go deep into solving tough questions. Thank you. Alright, so we just finished part A. You know, part A, though these things in one video, yeah, I made it that way because I wanted to separate that first number of moles calculations part so that we have the ability to like differentiate stuff to get. So we have moved. Remember, part A has to do with number of moles calculations, and then mass relationships. So we have actually talked about mass relationships. Next now is what what we are going to do in part B is that we are going to do mass volume relationships and worked examples, and then we'll now do past questions on both mass relationship and mass volume relationships. This is what I'm going to do in this video. Then in part C, we're now going to stoichiometry of solutions. That is what has to do with concentration and everything. Then part 4, we'll now go to, in that stoichiometry of solutions, also do molality and normality there. Then part 4 of the video, we are going to talk about limiting reagent, excess reagent, and probably we'll talk about 𝗁𝗵𝗁𝗀𝗍 as the case may be. Oh god, sorry, I just dropped my marker. I have to go get it. So just give me 1 minute. Alright, thank you. So let's go straight to the points. So we're going to talk about mass volume relationships now. Mass volume relationships. That's the relationship between mass and volume. Okay. Alright. That's 𝗁𝗵𝗁𝗀𝗀. Now, in mass relationship, we talk about the fact that they will give you one mass, ask you for the mass of another compound you get, or reagents or products. Now, this one is just almost the same thing, but this one they're going to give you mass, ask you for volume, or they'll give you volume, ask you for mass. But basically, everything we talk about revolves around mass and volume. Remember, a balanced chemical reaction is actually needed for us to be able to answer questions under this part. You get, and then it's just the same procedure, but then this time we are now comparing using what number of moles. You don't compare using mass you get, you compare using number of moles. Even the other that we go for, please, if you actually don't understand the first video on number of moles, please I would recommend that you go and watch it, because everything we're going to do now is that it's going to be centered based on that, but we're just going to be going deep into it. Do you understand? So let's go into mass volume relationship. You get, like I said before, they'll give you the volume of one reagent or chemical spreadsheet, and then they'll ask you for the mass of the other one, or vice versa. You get, let's do example 1. Example 1. Now let me give you a particular reaction. C chlorine plus hydrogen gas will give you hydrogen chloride. And I say in the reaction above, what volume of chlorine is required to produce 3.6 grams of HCl? Very simple question. H goes to 1, Cl goes to 35.5. Why? That's just it basically. You get, now you see the question now. This RX, and if you see it something like this, it actually means reaction. So the question they're asking us that in the reaction above, what volume of chlorine is required? And if they say chlorine, of course, you know that they're talking about chlorine gas. So what volume of chlorine is required to produce 3.6 grams of HCl? You get, it is very, very easy. Now remember, this is mass volume relationship. Why? They're asking us to look for what volume. Now we're looking for volume, and they give us mass. You know, you can actually say this thing is similar to the first mass that we did. But that one, they will not ask you what mass of chlorine. But this time they're asking us what volume of chlorine. Trust me, it's as easy as the first one. So I'm going to solve one of the scenarios first. And then, please let me shift it. Then, we'll not do more. Okay? Now, remember this is mass volume. The link of volume will give us mass. Please remember that we compare I told you in the best method that I'm going to teach you is how to compare using what? The number of moles you get. That's going to help for sustainability. Like for almost other parts that we're going to talk about, it's still going to touch around number of moles. Do you get? It's still going to be centered around number of moles. So let's compare. Now please take note that most times the major issue with stoichiometry is that most times they will not give you reactions. That's just it. That's why I said it before, that you have to have knowledge of a lot of reactions in your head. You have to be a chemistry student. A good chemistry student knows a lot of reactions, preparation of gas. So what I would recommend is that go and read acid, base and salts. Read acid, base and salts, read neutralization, check those reactions, understand it. Then read descriptive chemistry, or what you call mentals and non-mentals. Preparation of gases, you get reaction of different reactions. electrolytical extraction reaction, all those reactions, just learn them. So if you know all those ones, and also if you want to weekend to you in stoichiometry, they will ask you questions also with your organic chemistry knowledge, like addition reactions, substitution reaction. You get, so if you can read acid, base, and salt very well, read non-metals, read metals, and read organic chemistry, you are good to go. So they give you any reactions, but the reactions are not very hard. They are just basic reactions that you're supposed to do as a chemistry student. So let's go straight to the point. Now this one, because it's an example, that's why I'm actually giving an equation. With time, I will not give an equation. Now the reaction, see the reaction above. Now the thing is that whenever I do stoichiometry, I've said it before that we work with a balanced chemical reaction. We need a balanced chemical reaction. It's very, very important. Now the first question you want to ask yourself is this reaction is balanced? Is this reaction balanced? Remember I said before, I'm not going to teach you how to balance reactions here. Neither am I going to teach you how to calculate molar mass here. Because I believe some of you, because of your secondary school background, you don't really know how to do these stuff. Now, I know I'm not using it to mock you or something like that, no. What I want to do is that I have a friend of mine, he has a YouTube channel called Chemistry with 𝗵𝗶𝗀𝗆. Let me type it, go and search for it now. Chemistry with 𝗵𝗶𝗀𝗆 channel. So you know what his channel is, Chemistry with 𝗵𝗶𝗀𝗆, you get. So go and search for it and look for his videos. I believe he has taught some of all these basic stuff, like how to calculate for molar mass, how to balance reactions, you get. So you can get all those stuff there, you can learn it. Now, you see the reaction above, what volume of chlorine is required to produce 3.6 grams of hydrochloric chloride? Now we're looking for volume, they are giving us mass. Remember we compare using number of moles. So we want to balance the reaction. Is the reaction balanced? So we have 2 molecules of chlorine here, we have 1. So just put 2 here. It's going to balance. We are going to have 2 chlorine, 2 hydrogen, just the way it is. So it's balanced. Now what are we concerned about here? Chlorine and what is this guy? Because they gave us the mass of this guy, they are supposed to look for the volume of this guy. So what we compare is that 1 mole of chlorine gas produce 2 moles of what? HCl. That's the first thing from the equation, right? From the balance equation. The other thing is that we want to use this 3.6 to calculate for number of moles. Remember that number of moles is equal to mass over molar mass, right? What is the mass here? 3.6. What is the molar mass of HCl? We have calculated this stuff many times. HCl is H plus Cl. H here is 1. Cl is 35.5. Look at it here. So we have 36.5. So essentially as 3.6 over 36.5. Hold on, let me use the calculator. So 3.6 divided by 36.5, we have 0.099 moles. You get 0.099 moles. Let's just leave it like that, sir. 0.099 moles. You get. So that will not be the. So what we have to say, if we have gotten the number of moles for hydrogen chloride. Then we'll not get we'll not say S moles of chlorine will be what? Will be needed to produce what? 0.099 moles of HCl. As usual, what do? Cross multiply 1 times 0.009, we have 0.099 is equals to 2x. So it means x equals to what? 0.099 divided by 2. Sorry, 0.099. 99, that's American is 0.099 divided by 2. That's 0.0495 moles of chlorine. So this is the number of moles of chlorine that we added to give this mole. And that's not this. You have to convert this mole to what volume now. That's just the basic. Okay, it's very, very easy. So now remember that number of moles is equal to volume. See why I said number of moles number is not wasted. Over 2.4 dm3. Or it can also be 2400 cm3, but let's use dm3. You get. So we are going to bring this number up. Let's cross multiply. So volume at STP is equal to number of moles times 2.4 dm3. What is the number of moles that are calculated now? 0.0495 times 2.4. So you get 0.0495 times 2.4. So now that it is what? 1.12 dm3. So the volume of chlorine gas that is required to produce this mass of HCl is what 1.12 dm3. Chase is very simple. It's as simple as that. Very easy. You get. Please don't let me get my phone. You can go through, you can pause, and then let me just explain everything again. So remember, this is mass volume relationship. So it means they can either give you mass, ask you for volume. Please, they can give you mass of one of the compounds or element, whatever, ask you for volume, or they'll give volume, ask you for mass. In this case, they give us mass, ask you for volume. They can also give us volume, ask you for mass. You get. You're going to see some situations like that as we move on. So you get. So the first thing I said, the basics. I just want you to get used to comparing number of moles. From the balance equation, we are seeing that, okay, you know, if nothing is sitting between before Cl, means it's 1 Cl. So it means one mole of chlorine gas will produce 2 moles of HCl, right? Now we're not looking for the number of moles because that's not to do for the volume of chlorine. We have to get number of moles of chlorine first. That's the essence of the whole number of moles stuff. You get. So we have to look for the number of moles that will produce. Now from this information, since we already know molar mass of this guy, and number of moles goes to mass over molar mass, we can actually put the mass here over the molar mass 6.5 and get the number of moles of this guy. So that's the number of moles that is formed. So from this comparison, we now get that, okay, this is the number of moles of chlorine that will be needed. From this number of moles, can I convert to volume? That's just it. Please don't let me get questions from my phone. Okay, see how easy it is. So stoichiometry, it is not. Just needs you to, just have to understand. Okay. Now I have another example. I have a question here. Now remember I said you should know equations. That's just what I want to work on. Now go and know reactions. Do some reactions. Basic ones. Read acid, base, and salt. Read descriptive chemistry, metals and non-metals. Read organic. Okay. So let's go. Example 2. Example 2. What is the volume of suppose this oxide formed when 16 grams of SO2 is burnt in air? Give it that H equals 32 or H equals 16. See, very straightforward question, no equation. Give that. So now they say what is the volume of SO3 formed. So it means SO3 will be at the product site. The thing is that if you don't know this equation, there are sometimes the fact that they say SO3 will form does not mean that might be the only product. Sometimes you have more products, but the person that is setting the equation just wanted to tell you that okay, that's what they are concerned about. So you have to know these reactions. So you say when sulfur oxide is burnt in air, air is oxygen, so it means SO2 reacted with oxygen forms SO3. That's what basically they are all gases. Gas. Is it balanced? No. Because we have 4 oxygen here, we have 3 here. You get. So for we have 1, we have 1. So how can we balance this guy? If we put 2 here and put 2 here without solve it, let's check. We now have 2 sulfur. Oxygen is now 6 here. Oxygen is now 6, so it's balanced. So this is the balance equation. Please say if you cannot balance the equation, you are just going to do trash. Now remember, we are looking for what? We are concerned about this guy and this guy. You get? Because why? This is what we are looking for, is volume. They give us the mass of this guy. So let's calculate. We will compare the number of moles to form the equation. We see that 2 moles of SO2 produced 2 moles of SO3. Now let me just give you an arc or something like that. Now whenever you have the same number of moles or equivalent number of moles like this, for example, we are comparing, we have 1 mole of this produce 1 mole of this, or 3 moles of this produce 3 moles of this, or just like this one, 2 moles of this produce 2 moles of this. No need to do that comparison. You get it. Just know that the number of moles for both of them will be the same. How will I put this? Okay, let's just go here. Now if I'm not answering this question, I just have to, the only thing I have to press my head is I have to convert this guy to number of moles, because they have the same number of moles. So even when you use this guy, when you use this guy to do number of moles to mass over molar mass, and put it to this equation, when you still compare, you are still going to get the same number of moles here. Let's see what. Let me put it into play now. Now remember, 2 moles of this produce 2 moles of this. You get. Now they give us 16 grams of SO2. So let's see the number of moles of SO3 that will produce 116 grams of SO2. Yeah, remember SO2. Let's go for the molar mass. S plus O2. 32 plus 16 times 2. 32 plus 32, which is 64. Abi. So it means we have mass. What is mass? 16 over 64. This should be 1 over 4, that's 0.25. Let me check. 16 divided by 64, 0.25. So we have 0.25 moles of what? Of what? SO2. So it means that's the number of moles we have to work with to compare with. So we now say 0.25 moles of SO2. We produce S moles of SO3. This one I'm going to tell you that since this comparison here, we already had equal stuff. 0.25 moles of SO2 will still produce 0.25 moles. They'll still be the same here. That's my point. So if you have 1 mole of SO2 produce 1 mole of this, and X mole will still produce the same. You get. In case you don't get, let's just do the long method, sure. So as usual, like 2 times X, 2X equals to 2 times 0.25. That's 0.5 over 2 over 2. Have you? So S equals to 0.25 over 2. That's 0.25 also. Moles of SO3 that we produced. Check, you see that you still got the same value. That's what I'm trying to prove to you get. So when you are adding the same number of moles from comparison, you still get the same what? Number of moles of the other guy. So remember, we are converting this guy to volume. And number of moles goes to volume over 2.4. Volume at ST or whatever. So the volume now is equal to number of moles times 2.4. What's the number of moles? 0.25 times 2.4. Let me put that later sharply. 0.25 times 2.4. We have 5.6 dm cube of SO3 that we produce. I don't know if you get, so that's just volume relationship. It's very easy. It's very easy. Should we go again? Okay. So let's go for example 3 now. So somebody is getting this because it's sweet and it's easy, especially when you have come to understand it. Look at example 3 on the same mass volume relationship. Example 3. Okay. 56 dm cube of sodium hydrogen charged carbonates was decomposed. Was what now? No, cannot be decomposed. Okay. Na2CO3 was dissolved in okay, was reacted. Let me just put this in this solution. Let me not go and touch beyond that chemistry. The question has been correct theoretically, but let me just say 36 dm cube of oxygen oxidized water to its higher oxide. What mass of H2O2 will be produced? Give it down. H is 1 and O is 16. Good question. You get solution. We need to watch the reaction first. You get, so what we are just talking about is water oxidizing to form hydrogen peroxide. You get, they are now asking us that, okay, look at it though. this thing, the volume of this guy is the 6dm³ that did the work. What mass of this guy will not be produced? We don't know. So if you are consistent with these two guys, first let's see whether this reaction is balanced. We have 2 hydrogen here, we have 2, we have 2 hydrogen here, we have 3 here. So let's put 2 here and put 2 here first. This balance is by trial and error. So we have 4 here now. We have 4 here. We have 4 hydrogen. We have 4 oxygen. We have 4 oxygen balanced. What are we concerned with these two? So we can say 1 mole of oxygen was ready to produce 2 moles of hydrogen peroxide. You get? Then now we are looking for the mass of this guy. And now give us that look at this value for the 6dm³ of oxygen. We can convert this to number of moles. Remember, number of moles is equals to volume at STP all over 22.4, which is equal to 56 over 22.4. Check it out now. So the goal is just to look at the remaining parameters. After you have the first stage of the comparison is always gotten from the balance equation. The second phase is to use whatever is given to look for number of moles from the way I've taught you before. You get, so we have 56 divided by 2.4. So we now have 2.5 moles. So it means now what is now reacting this time is 2.5. How do you get 2.5? By converting the 6dm³ to moles. So we now have that 2.5 moles of oxygen. We give what? S mole of H2O2. As usual, we must multiply, right? So let's do it here. Let me do it here. So now 1 times x is x. X goes to 2.5 times 2. If we do the number, just leave whatever moles, blah 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 blah. If it's 2.5 times 2 equals to 5 moles of H2O2. Because this x is mole of H2O2. I didn't provide that. So that's the number of moles of H2O2 that we produce. But is that the answer to our question? No, they say what mass. You get. Remember, number of moles goes to mass over molar mass. And mass, because multiply here, is equals to number of moles times molar mass. Now, what's the number of moles of H2O2? Let's put molar mass. Remember, H2O2 is empty as H2 plus O2. H2 is 1 times this 2. Plus oxygen is 16 times 2. This empty as 2 plus 32. That is 34. So it means the molar mass of hydrogen peroxide is what? 34. So mass now is equals to what? Number of moles is what? 5 times what? 34. 5 times 34. So it means the mass of H2O2 produced is what? 170 grams. Can you see how simple this stuff is? Very, very easy. Now, what is the difference between this one and the one I've done before? This one, they gave us volume, and we're looking for mass. The ones I've done before, they gave us mass, we're looking for volume. Basically, it's very, very easy. Very easy. Even when we move on, you see that the whole stoichiometry concept, it's not as hard as people hype it. You get. So I want to look for questions. We have done 3 examples now. Okay. I love this one. After we are still on work examples. After this part, we'll now go to ask questions. You have to ask questions on both mass and mass relationship problems and mass and volume relationship problems. You get. Right, so let's go. Example 4 now. Example 4. I'm solving many examples so that you see how it works. You get. Let me just calculate first. Now the question is the volume of CO2 produced from the reaction between 120 grams of sodium triazoxide carbonate for according to the equation below is what? So look at the equation. Na2CO3 plus HCl goes to 2NaCl plus CO2 plus H2O. Given this was 2HCl, given that Na is 23, C is 12, O is 16, chlorine 35.5, hydrogen is 1. See this one, they will give you a full reaction. It's very good. Now, what is the volume of this guy? So we are going to talk about this guy. So there is from the reaction of 120 grams of sodium 𝗪𝐶𝐴 4. What comprises sodium 𝗪𝐶𝐴 4 here is this guy. So it's still the same procedure, no matter how long the question is. It's the same procedure, right? Okay, let's go. Now, what we are talking about these two guys now, right? So, all we know is that 1 mole of this guy will produce what? 1 mole of CO2. Yeah, you get. Because see, 1, everything is balanced here. Everything is balanced from the equation. So remember I said when we have 1 like this, and when you now convert this 120 grams of this to moles, that's still going to be the number of moles of course. Should we verify? Let's go. Now remember the second step, because we're looking for the volume of CO2, but we have to look for the number of moles for this 120 grams of this guy first. So number of moles is mass over molar mass. What is the mass? 120 grams. What is the molar mass of Na to CO2? It's 106. Just all these things have, because I've solved so many questions back then, I actually know many molar mass in my head. But let's confirm. This is the same thing as Na2 Abi plus C plus O3. Na is 23, that's 23 times 2 plus 12 plus 16 times 3. Abi, this is 46 plus 12 plus 2 times 3 is not 48. 16 times 3. Yeah, 48 plus 48. Let me do math. Plus 12 plus 46. So we have 106. That's the molar mass of this guy, about 106. So 120 divided by 106. 120 divided by 106. We have 1.132. 1.132 moles of what? Na2CO3. Check it out. Now that's going to be what I'm going to compare here. So now 1.132 moles of this guy will now produce X moles of CO2. You get, you know our normal cross multiplication. 1 times X will give us X. This will still give us 1.132. So it means S, the number of moles of CO2 is also equal to 1.132. You get. So the next step is to convert this 1.132 of this volume, of this CO2 to volume. And how do we do that? It's easy, right? Number of moles is equal to the volume we are looking for, over 22.4. And this volume is equal to number of moles times 22.4. What is number of moles now? 1.132 times 22.4. So we have 1.132 times 22.4. We have 25.4. So we now have 25.4 dmq of 𝗁4. We can produce. Let's see how easy this stuff is. Very, very easy. Let me confirm the answer. That's just it. That's the answer. Let me see if we have another question here. Hope you can see that this thing is not as hard as you guys used to read it. You get. So stoichiometry is not hard. So we have 2 questions here. 2 past questions. Jam past questions. So let's take them as example 5 and 6. So we won't come out for this one. We are going to solve like 10 questions for this part. Then we'll talk about practice questions or past question on mass relationship and mass volume relationship. So we are going to solve like 10 jam questions on that part to call this whole lecture on mass volume relationship and mass relationship a day. We'll just call it there. So let's go. Example 5, which is a jam past question actually. Okay, let's go example 5. Example 5. JAMB pass question 1984 minus question 4. So you can go and check it out. So let's solve it. And the question says for the reaction is given as what? When A short M02, that's ammonium diazone 93 was decomposed to K. This is actually the derivation for one derivation for nitrogen gas. Please leave the state, it states their state effect. We are not yet to we are just here to solve question. Now they say calculate, right? Calculate the volume of nitrogen that would be produced at STP from 3.20 grams of the diazoxide nitrate salt. And there are options. Option A, 2.24 dmq. Option B, 2.24 cm3. Option C, 1.12 cm3. Option D, 1.12 dmq. And option E, 4.48 dmq. You can see now this question is quite complicated for some persons because we are having options in both dmq and cm3. You get, so what unit are we going to use for the volume? You can use any of the units, but just look for the answer that will keep. Yes, you can use for both cm3. Remember, number of moles when you have to do cm3 is volume at STP over 2,400. While for dmq is volume at STP over 2.4 AB. So let's get into it because that's not the major work here. First of all, the first thing I want to check if the reaction is balanced. Here we have two nitrogen here, we have two balance, 2 hydrogen here, two oxygen. Balance. What are we concerned about? They asked us to look for the volume of that nitrogen. Shall we look for the volume of this guy? That was 3. Now this is down nitrogen salt of this guy. So I'm talking about this two. So as you can see, 1 mole. So now let's solve. You can see that 1 mole of NH4 SO2 produces 1 mole of nitrogen gas. Here you are getting into. That's step 1. Step 2 now, we are going to convert this guy to what? To number of moles. Number of moles goes to mass by molar mass. What is the mass? 3.20. What is the molar mass? N of this guy, this is the 1093. So we have N plus H4 plus N plus O2. It's saying that the fact that this thing is 1093 does not mean this will be also 3. O3. You should know how to please. These are basic stuff. You should know how to name compounds also. Understand? You should know how to name compounds. Yes. You can go to those channels. I link all those basic stuff. You have actually taught them before. So you can go and get the videos. Okay. Now, this is it, Abby. So let's go for the molar mass. So the molar mass, what is nitrogen? Nitrogen is 14. They were not even giving the questions. See, I told you that you have to know relative atomic masses of elements. You see, nitrogen is 14. Hydrogen is 1 times this 4, 1 times 4, plus another 14, plus 16 times 2. You see, this is 14 plus 4 plus 14 plus 32. You get. Then we do this one to save time. Everything is 64. So the mass of this guy, 64 grams, the molar mass, I mean. So we are watching now. Let's wipe this for parts. Things are working here. So remember, I tried to get the number of moles for this guy. It will now be 3.20 divided by 64. That's 0.05 moles. So you have 0.05 moles of this guy. So we'll now come back and now say 0. It will still produce the same thing because it's 1 1. I said it before. 0.05 mole of this guy produce what? S mole of nitrogen. Because multiply 1 times x is x. This thing times 1 is still 0.05 moles of what? Nitrogen gas. Now look for the mass, the volume, right? You get. Now remember the number of moles is equals to, this is the number of moles of this guy, volume at STP. That is in dm cube over 2.4 dm cube, or volume at STP in cm cube all over 2400 cm cube. I believe you know this already. The question is which of them do you use? Because in the option now we have both dm cube, we have cm cube. So let's use dm cube and use cm cube. You will see the difference in the two answers. So you know everything I explained with my mouth. It's good to see it. So let's start with the first one. So in both cases, the volume is equal to number of moles times 2.4. That is when you are using dm cube. So we have, what is the number of moles? 0.05. What is this thing? That's 0.05 times 2.4. That is 1.12. 1 times 2.4. So it means the volume of nitrogen at STP is 1.12 dm cube. See, we have used dm cube. Let's use the same formula and solve for cm cube. Remember, the number of moles goes to volume in cm cube. If you multiply, we have volume, but in cm cube now, this goes to number of moles times 22,400. You remember now. So what is the number of moles here? The number of moles here is 0.05. That is 22,400. Okay, so we have 1,120. So we have 1,120 cm cube. So you see now that, check the options. Both of them are correct, but in a different unit. Do we have anything like 1,120 cm cube in the option? No, but we have this 1.1. So where is it? That's option D. So option D is very correct. So don't want to mistake this solve and get this thing and go and put cm cube. That's why we have two different. So you see how the formulas work now. So what we see as jam questions are not as hard as they should tell you. Okay, so let's go. I believe this is clear. So let me grab the board and do example 6. It should be the last one for this volume, mass volume issue, before we dive fully into solving a lot of past questions. So I have to make everything very, very clear for you. So when you see questions under this topic next time, there will not be a walkover. Okay. So, I'm just trying to manage my markers. Okay, example 6, which is what? A jam pass question. That was asked 1991. Question 7. Please give me 1 minute. Let me quickly rush to get a new marker, a red marker, so it can be visible. 1 minute. Alright, so I've got the marker. Let's go. It says calculate the volume of CO2 measured at STP that is produced when 1 kg of potassium hydrogen 𝗂𝗏𝗀𝗀𝗃 for is totally decomposed by, you see this question now, they did not give you any equation. So if you don't know this reaction, how do you get it? See, my point still stands. You should go and learn equations. 828 dm cube. This how we see this is a jam question. See, this is how jam can be wicked. They will not give you anything. 112 dm cube. D 196 dm cube. They do not say gas molar volume equals to 2.4 dm cubed. And also they said potassium is 39, you should know already. O is 16, C is 12, H is 1. So you get. So this is the question. So jump past question, you go and confirm it. 1991 question 7. So let's do the solution. The first work they give to us is to crack what this equation looks like. What is the volume of CO2 measured at SPP produced from 1 kg of potassium hydrogen 4? And that compound is KaCO3. And please take note that when this guy decomposes, you should read acid and salt. When you are going to salt, you see this equation, check your lambda. Every on this when textbook, this thing will decompose to give you KaCO3 plus CO2 plus H2. It's just a typical reaction of hydrogen 𝗬𝗵𝗁. When they decompose, they form their respective 𝗬𝗵𝗁, 4 chlorophll and water. So if you still combine these three, they'll give you this. You get. The thing we want to check now is if please leave the state of matter. I need to tell you that any equation that the state of matter is not involved is wrong, but we are not submitting this into anybody. We are solving for ourselves. So let's check whether these things. Now we have 2K here. Let's just put 2K here to balance it, right? So let's see now. We have 2K here too. We have hydrogen 2 here. We have C2 here. We have 2. Oxygen is 6. We have 3 here. 2 here. That's 5. Very, very balanced. So what are we concerned about? Let's say volume of CO2. Produce some certain mass of this. Let's say 1 kilogram. Please take note that the standard unit for mass in chemistry is gram. I've said it before. Why the standard unit of mass in physics is kilogram. So it means in chemistry they give 1 kilogram. You have to convert it to 1,000 gram. You get. So we are going to compare with the same method, number of moles. So we say 2 moles of this guy produces 1 mole of CO2 from the equation, balance equation. Then next we want to calculate the number of moles of this guy from this information of 1,000. No, this is mass over molar mass, and the mass here is 1 kg. You get, which is empty as 1,000 gram. All of what is the molar mass of KaCO3? Let's calculate. It's empty as K plus H plus C plus O3. K is 39, H is 1, C is 12, O3 is 48. So it's empty as 40 plus 12 plus 48. This will give us 60 plus 40, that will give us 100. But let me press calculator just in case matters no accurate. Plus 40 plus 12 plus 48. Yeah, that's 100. So it means the molar mass of KaCO3, that's potassium hydrogen 𝗬𝗵𝗁 4, is actually 100. So we have 1,000 divided by 100 here. That is 10 moles. So it means 10 moles of this guy will produce S moles of chlorophll. 2 times X is 2X equals to 10. So divide by 2, divide by 2. X is actually 5 moles of what? CO2. That's the number of moles of chlorophll that will produce. So we want to convert that number of moles to volume now. Remember, number of moles equals to volume at STP whatever over 2.4 dm cubed. Why are we using dm cubed? All the options are in dm cubed. Check that. Then the volume is now what? Number of moles times 2.4. What is the number of moles? 10 times 2.4. This is simply as what? This is 10 times. Okay? It's either 224 dm cubed. But now we don't have this in the options. Okay, let me see. We actually missed it. Let's check the equation. 2 here, 2 here. 3, 5, 6, 6. Okay. Okay. Let me check if there are options I did not see. Okay. 1,000 divided by 100 is 10. Please take note this is supposed to be 5, right? We have 5 moles of CO2 that was produced. So we have times 5 or times 10. Yes, we now have 5 times 2.4. This is 112 again. So we have 112 dm cubed. 112 dm cubed for what? And what is 112 option B? So So guys, that is it. So you can see how easy mass relationship and mass volume relationship when it comes to stoichiometry. It's very easy actually. It's not hard. It's not hard. So that's it. So what you have to do, if you don't understand, please go through this video again, and please make sure you watch. We're going to continue now. We're going to talk about classworks. But before we do classwork, make sure you understand all these stuff first, because the class we're going to talk about, there are questions that are technical. Remember, I said for you to understand how to create all these questions by yourself. Now, this one did I know it because I know sorts. I know that child components, these guys, when they decompose, they're not stable. They will form these guys. Yes, so that's just it. Alright, so it's time for us to take questions. So pass questions on both mass relationship and what jump pass questions specifically. So let's see if what I've taught, if there's to ask it, and let's see the complexity you get that will be involved when they ask it. So I have 8 odd jump pass questions. Now we are going to state the you can actually go and check them out and check more. So with these 8, I will really touch a lot, and then in the next video we'll then move to stoichiometry or solutions. We'll talk about modality, normality. Then after that we'll stay there for a very long time because there are a lot of tough questions. There are people who handle a lot of questions. Then after that we'll now move to limiting access to agents. Then maybe I will now do water preservation, maybe to make the video just all encompassing. Alright, so let's start with the first question here. First question says, now phosphorus bonds in oxygen. Phosphorus bonds in oxygen according to the equation. Let me write the equation. P4 plus I go to plus P4 or 10. Now you now see how many liters of oxygen will be required at STP for complete oxidation of 12.4 gram of phosphorus. Given that P is equals to 31, O is equals to 16, and molar volume of the gas at STP equals to 2. Alright, so we also have options. Our option A, 5.20 dm3. We have option B, 11.20 dm3. We have option C, 2.24 dm3. We have option D, which is 20.20 dm3. Now option E, 6.20 dm3. Alright, this is a typical mass volume problem. Now they're already giving us the equation. Please, this is jam pass question. Okay, this is jam 1979 question 42. So I'll be writing the year so that I can go and confirm. But just in case your past question pick rubbish, I'm not solving anything wrong here. It's your past question that is wrong instead. You get. So let's go. Solution. Alright, now they are giving us the mass of what? Phosphorus, right? So we are working with this guy. So we look for the liter of oxygen. That's one of oxygen. Now it's just easy. The thing is that no matter how complicated you think the question is, just get understanding, you get. This one is even the simplest because they give you the equation. So we can see that 1 mole, because forget this 4, it's still one that is standing here. So 1 mole of phosphorus was reacted with what? 5 moles of what? Oxygen. So let's convert this 12.4 phosphorus to molar mass. So we are looking for what now? The molar mass of this guy here, or P4. And P is 31. So it's 31 times 4. She get what is 4 here. Let me press my calculator. 31 times 4 is 124. She is 124. And remember, number of moles equals to mass over molar mass. What is the mass? 12.4. What is the molar mass? 124. I think we have 0.1 here. Let me check. 12.4 divided by 124. 0.1. We have 0.1 moles. So we now have that 0.1 moles of P4 will produce X moles of oxygen. So 1 times X, 0.1 times what? 5. That's 0.5 moles of oxygen gas that we produce. Let me just confirm this thing. 0.1. Okay, that's 0.5 moles. So this is the number of moles of oxygen that we'll get. But the answer for the volume is easy. Remember the number of moles equals to volume they are looking for. Why are we using DMQ? Because all the options are in DMQ. So it means volume here equals to number of moles times 2.4, which is 0.5 times 2.4, which is given as what? Okay, 0.5 times 2.4 should be half. That's 11 into DMQ of oxygen gas. That is this guy. Tracy, very, very, very easy. Let's go to answer number 1. Let's go to the second question. Question 2. Okay. Question 2 says this is Jam 1986 question 2, right? It says what mass of a divalent metal M which has atomic mass of 40 would react with excess 𝗁𝗵𝗁 acid to liberate a rate 224 cm3 dry hydrogen gas measured at STP, given that the gas molar volume is 2.4 gmp. And of course, we have options. Option A says 0.0 gram, option B says 4.0 gram, option C says 0.8 gram, option D says 0.4 gram. Now this is a typical jam question. You get typical jam question, not even a typical one. It's a real one. Now they ask us what is the mass. We're looking for mass, and they give us volume. This is mass volume relationship. Now the thing is that they don't give us the divalent metal. So best is can do these things somehow. Then since they give us the atomic mass of M as 40, and when that calcium has atomic mass of 40, it means that M is calcium. But let's not conclude. We actually use the information we have to solve. Now please take note that the fact that it's divalent, because we need an equation. The fact that it's divalent does not mean you want to write it as M2. You get. Valency is not the same thing as what you have there. This is just like a gaseous molecule, or we say 2 atoms of M, or a molecule of M. So where the valency comes in is in the reaction with HCl. So M plus HCl give us what? Now this is going to react with this. We are going to have MCl2 plus H2. Why do I know that MCl2 and not MCl? Because M is divalent, valency is 2, chlorine is having a valency of 1, but now M times 1, Cl2, which is MCl2. Please, if you don't understand this thing I just did, please learn what topic is this now? basic chemistry now, valency, not valency. Maybe that it has everything on that. So let's balance our equation. We put 2 here to make it balance size. So we are good. So what we now say is that where our concern is M and what? Hydrogen gas. I look at the mass of this guy. So we say 1 mole of this guy produces 1 mole of hydrogen gas. Now they now give us the volume of hydrogen gas as 2.4 cm3. Remember that that volume over what? 2,400 cm3. For one to write the number of moles to contain, I believe you already know this stuff. Now what is the volume given? Why are we using cm3? Because the volume is cm3. So we have 2.4 divided by 2,400. So now let me divide my calculator. We have 224 divided by 2,400. That is 0.01. You get. So that is 0.01 moles of hydrogen. So if you do 1, we have x here, give us 0.01. You see how that x also 0.01 moles of M. So let's for the mass. Remember, number of moles is equal to mass over molar mass. And mass, if you got multiply, equals to number of moles times molar mass, right? I look for mass now, right? So what is the number of moles? 0.01. What is the molar mass? It's really here 40. And this will give us 0.4 gram. Change that. So that is it. That's why option D is correct to that question. I hope you get. If you don't get, please take the video back and watch it again. We have done so already. 6 more questions to go. Let's see how easy they are now. That's good. I've solved a lot of questions. These are not the hard ones, so we'll get to hard ones now. Number 3. Wow, this question is long, my god. Okay. Number 3 says in the reaction, that is reaction of what? Calcium carbide. They put this, they can just manage there. 2H2O liquid give us calcium hydroxide 2 plus C2H2 at a time. It's also a gas. This is the equation. So now say what is the, see this is from under organic chemistry. What is the mass of solid calcium carbide needed to produce 1,000 cm3 of acetylene gas. This thing a time this is called acetylene here. Acetylene rather. C is 12, C is 40, the GNQ is 2.4 GNQ. Well, this project show me videos again, we already know they're happy. Alright, so let's go. Now option A, which is what? 3.8 gram. Option B, 2.9 gram. Option C, 2.0 gram. And option D, 1.0 gram. Let's solve solution. Okay, let's do solution. Okay, let me solve now. Now, please take into all these reactions. This question said people that have sent it, they have what the mind of God in them. Most times they will not give you any equation. So you have to know. I've said it before. Acid base and salt, non-metals, metals, organic chemistry. We just topics. All these reactions are not there for you. Okay, so they will give us this one. So they're asking us. Let's say whether it's balanced. We have 1 calcium here, 1 calcium here. Good. We have 2 carbon here. We have 2 here. We have hydrogen 2 here. Sorry, 4. We have 4 here. So we have 4. It's balanced. So asking us to look for the mass of this guy. Needed to produce this thing of acetylene. Okay, so what's the acetylene here? That's a time. So it's mass volume relationship. So what are we concerned about here? This and this. Remember, they only 1, 1. I don't know if I should start using that short method, but let me just keep doing the conventional method. On the normal day, since they only 1, 1, you don't have to stress, but let's just take stress. So we have that 1 mole of calcium carbide. We have to produce 1 mole of acetylene. Now we now give us 1000 cm³ of acetylene, so we can now get the number of moles of acetylene. If I say volume is cm³ over 2 to 400, which is 1000 over 2 to 400. Let me use my calculator. 1000 divided by 2 to 400. 0.045 moles. So we have that this is what? 0.045 moles. So it means S mole of this carbide will give us what? 0.045 mole of this guy. So you can multiply 1 times 0.045 or 1 times x mole of CaCO2 is equal to 0.045 moles. So that's the number of moles of this guy. You get. So what are they asking for? The mass. So we can have from here that the number of moles to mass over molar mass, and then mass, if you can multiply from here, equals to number of moles times molar mass. We already have the number of moles. Let's put the molar mass of this guy. So calcium carbide is simply as calcium plus carbide 2. You get. That's carbon, which is simply as what is this? 40 plus 12 times 2. Abi, this thing is 12 normally times this 2. So we have 40 plus 24. So we have 64 here. So it means here molar mass is 64, and number of moles was 0.045 and 64. So the mass of what? Calcium carbide is 0.045 times 64. 2.88. So we have 2.88 grams. Those are the options. Okay, if you approximate 2.9 grams, so B is very correct. You get. So you see how this thing is. It's not easy. Easy. So stoichiometry should not be of fear again. Get. Stoichiometry should not be of fear. Okay? Stoichiometry should not be of fear. Okay. Let's go to the fourth one. Wow. This one is what? This is, you can write Jambites here later. You have 𝗁𝗵𝗆 plus 𝗁𝗵𝗁 gas equals, this is combustion reaction of propane gas plus 𝗁𝗵𝗁 gas. That's it from the equation. Comma, the volume of oxygen at STP required to burn 50 cm³ of propane is what? A, 250 cm³, B, 150 cm³, C, 100 cm³, then D, 50 cm³. They don't give us anything in the brackets. So this is Jambites question. Jam 1994, 1998 question 4. Alright. Solution. This one is not still hard. For anyone that they give you question, just know that one is bonus to you. Now look at the equation. Let's see if it's balanced. We have TDC here, TDC here. If it's balanced. Now they're asking us to look for the volume of oxygen volume of oxygen. Okay, we are concerned with this guy. We have to burn 50 cm of propane. This is propane. So it's inorganic chemistry. So you see this one is even volume reaction, right? Volume reaction. It's very easy. It's very easy. It's the same logic. So let's compare. We are comparing with these two guys. So 1 mole of this guy react with 5 mole of oxygen. Then that gives us the volume of propane. So let's look for the number of moles with this. Number of moles is equal to the volume in cm cube all over 2400, which is empty as 1000. Is that 1000? Okay, 50. Sorry, 50. Divided by 50 divided by 2 to 400. So we have 2.23 times 10 to minus 3. You can get the number from. So it means we are looking for the volume of oxygen, right? So it means S mole of oxygen will react to this value 2.23 times 10 to minus 3. You get it? If you go multiply, we have 5x equals to 2.23 times 10 to minus 3. If you divide both sides, you have that x equals to this value 2.23 times 10 to minus 3 all over 5. So 2.23 times 10 to minus 3 divided by 5. We have 4.46 times 10 to minus 4. This is what? The number of moles of oxygen that reacted. So now we're going to use number of moles to look for the volume. Remember, number of moles equals to what? Volume or no volume that we are looking for. We are using cm cube because all the option is cm cube. All over 2 to 400. Because multiply volume is equals to what? Number of moles times 2 to 400 cm cube. What is the number of moles? 4.46 times 6 minus 4 times 2 to 400. Let me multiply. So we have the volume as 9.99 cm cube. We have approximately 10 cm cube. And that is what? It's not here. Wow. Okay. Let's see your made a mistake. Let's go again. So the volume of oxygen at STP required to burn is just 50 cm cube. Okay. Yes, 50 cm cube. C3H8 plus 𝗂𝗵 plus SOH2 plus CO2. Okay, I'm sure we made a mistake somewhere. See the mistake. Okay, it's not a mistake actually. You see the volume of oxygen. So 1 more of this guy. Okay, see where I made the mistake. See it. See why I need to be very careful. I need to be very careful. Let's go again. Okay. Now 1 more of this guy. See, the only time I did not write, I did not specify the particular compound. I know before I write things like this. The only time I did not do it now, I made a mistake with it. It's okay. Let's write it. We are producing 5 moles of this guy. O2. You get it. And then I give the volume of propane. I will calculate it from 2 points. 2.23. Let me do it again. So, then I said, we can use it to calculate number of moles. Because number of moles goes to volume in that cm cube all over 2 to 400. So that would be 50 over 2 to 400. So 50 divided by 2 to 400 is 2.23. So it means we now add 2.23 times 10 to minus 3 moles of this guy to produce S mole of what? Oxygen multiply. S equals to this value times 5. So we have 0.011 moles of oxygen. And that's not all, right? Remember, number of moles equals to, we are looking for volume now. Volume over 2 to 400. That's volume in cm cube, right? Why are we using cm cube? Because you're trying cm cube. So it means the volume we are looking for, the volume of O2 is equals to number of moles times 2 to 400 cm cube. And this volume will be in cm cube. So the volume, the number of moles is 0.011 times 2 to 400. Times 2 to 400. So we have 50 cm cube of oxygen. So that's option A. It gets. Alright, so let's move on to the next. I think this is the third one, the fourth one. I think it's either the fourth or the third. So we have like 4 or 3 more to go. I believe you're enjoying this. Okay, so let's go for the next one. That was number 4. Let's go to number 5. This is what? JAM 2004. Question 33. Let's go. So what volume of gas is evolved? What volume of gas is evolved at STP? What's STP? Standard artificial pressure. If 2 grams of calcium 𝗁𝗃𝗀𝗆 or is added to a solution of 𝗁𝗃𝗀𝗆 acid. Let's take options. I had the option here said A 24 cm3, B 112 cm3, C 2240 cm3, D 448 cm3. And this is JAM. Yeah, I'm using it for JAM 2004 question. Okay. So let us save. Now you see there's no equation. No equation was given. This is how normal questions are. So for your answer, you don't know what when calcium 𝗁𝗃𝗀𝗆 4 reacts with HCl, and you know to answer this question. So what happens is that this is calcium 𝗁𝗃𝗀𝗆 4 plus HCl to give us calcium chloride plus H2. Sorry, calcium chloride plus CO2 plus H2. This is another form of neutralization. Salt plus acid will give us, sorry, 𝗁𝗃𝗀𝗆 plus acid will give us the salt, CO2 and H2. And this equation does not require balance. Let's see, one with one here. Okay, I think perhaps 2 here. 2 chlorine here, 2 chlorine here, 2 hydrogen here, 2 hydrogen here. Oxygen is 3, 1 plus this 2 is balanced. So what are we considering with this? What volume of what gas is involved? What is the gas here? It is this guy. If you check this, this is gas, this is liquid, this is what? Solid. You get, so the answer we are concerned about this guy. So when 2 grams of this guy is added to a solution of gas, so you just see normal logic. Let's compare. So we have that 1 mole of this guy produces what? 1 mole of this guy. So let's compare these 2 grams of that. And remember, calculate 3, calcium 𝗁𝗃𝗀𝗆 4. The molar mass is 100. Calculated by yourself exceeds. So the number of moles equals to 2/100, which is 0.02 moles. So now that 0.02 moles of this guy will produce X moles of this guy. And unfortunately, if we check, we will have that X is equal to 0.02 moles of CO2. When you do your question multiplication, I've told you before that X is the same way. It still seems to be the same way. So now that I'm getting it, remember that number of moles equals to what? Volume we are looking for. Is CM3 global to 400. I think we have done this still with the answer, so it should not be new. Now the volume we are looking for is equals to number of moles times 2 to 400. Right? What number of moles? 0.02 times 2 to 400. Let me press my calculator. We have 0.02 times 2 to 400. We have 448 cm3. So the volume we are looking for is 448 cm3, which is option D. Do you get? It's as easy as that. I believe this is already too simple to do now. It's not. Please, you have to write. You have to do option to go back. This is not like in life class when you tell me to go back. I'll feel angry. so I can take it back as many times as possible. We're in question 6. Okay, good. Question 6, this is what? Jan 2004. Question what? 24. Most times you must listen your past question because there are different past questions. You get if a solution contains 4.9 grams of tetraol sulfate 6 acid, calculate the amount of copper 2 oxide that we react with it. For the sake of God, let me just give you these values. You should know that copper is 64. Copper is Cu64. O is 16. S is 32. And H is 1. Let's take options. Option A, 40 grams. Option B, 80 grams. Option C, 12.3 grams. Option D, that for 4 grams. You get. So now this question will be asked to the persons because number 1, no equation was given, so you have to put the equation yourself. Number 2, people don't know formula for copper 2 oxide today. You won't go and write CO2. That's not the answer. See why the chemistry knowledge is needed in stoichiometry. You get. Right, they say if the solution contains 4.9 blah blah H2SO4 and it reacts with CO. So the reaction here is H2SO4 plus CO. This is copper 2 oxide. Yes. We give you what? The reaction will now give you CuSO4. Like this guy will this guy, this guy will this guy. Plus H2O. How did I know normal reaction? Let's see if it's balanced. One C here, one Cu here. So what that you are everything is balanced. Oxygen is like 5. You get. This is a normal reaction. You get. Okay. Now this is also possible. Copper is also able to displace this gas on normal depot. They just so now stoichiometry. Okay. So now what are we concerned with H2SO4 from the question? I look for the amount of this one. So you see, 1 mole of this guy will lose 1 mole of this guy. So whatever is calculated for the number of moles, that will still be the number of moles of this guy. That's the logic I want you guys to know. If they are just the same, no need to compare them. You get. So let's look for the number of moles. They said the mass is 4.9. I told you that H2SO4 before. I told you that it's 98, the molar mass. We have 4.9 over 98. You get 4.9 divided by 98. We have 0.05 moles. 0.05 moles of what? H2SO4. See, the fact that this is only 1, that's still going to be the. Let's just do it. So we have 0.05, we give x. S times 1x is still going to be 0.05 moles of CO. But then you have what I was asking before. They say we look for the mass. Remember that number of moles is equal to mass over molar mass. And then mass is equal to number of moles times molar mass. What is the number of moles? 0.05. What is the molar mass? Let's calculate. CO is the same thing as Cu plus O. Cu is what? 64. O is 32. O is 16. Right? That is what now? Is that not 80? Sorry, let me just press 60 plus 62. 64 plus 16. That's 80. So Cu is what? 80. We have times 80. So if you multiply, and we now have that 80 times 0.05. 80 times 0.05. We have 4. It means the mass of Cu equals to 4 grams. And that's option D. Chasey, this thing is easy die. Okay, when we say easy die, get easy die. Okay. That was example. That was work example 6 from the past question. Okay, shall we move? This is 7. Okay, 7. This is JAMB 2006 question 15. Let's type the question now. They give a particular reaction sheet. Okay, so this is gas plus 5O2 for gas also. They give us 4CO2, which is gas, plus 2H2O. So this is a combustion reaction. Then in the reaction above, right, the mass of CO2 produced on burning 78 grams of ethane is what? Let's take options. Option A at 9 grams, option B 252 grams, option C 264 grams, option D 156 grams. C is 12, O is 16, right? H is 1. Shall we? Let's do solution here. Right? Solution. The equation should be balanced already. Now we are looking. What are we concerned with? This guy. This is ethane and this guy. So let's compare. See the number of moles. So we can say 2 moles of ethane produce 4 moles of CO2. Then that says 78 grams of this guy. And this ethane is C2H2. Abi? So the number of moles of this thing is 78. That's mass over the molar mass. What is the molar mass? Let me go write it in case you are not following. You get what is the molar mass of C2H2? Because C2H2 is simple as C2 plus H2. Which is simple as 12 times 2 plus 1 times 2. Which is 24 plus 2, that's 26. Right? Remember that's 26. So we have 78 over 26. So let's see what value that will give us. 78 divided by 26. We have 3 moles. That means it's 3 moles of what? Time. C2H2. Okay, see now. So we are comparing with this guy. So 2 moles of this guy will produce 4 moles of this. Then 3 moles of this will produce X moles of this. But then we have to X equals to 3 times 4, 12. So about 2. So then you have 6 moles of what? CO2 that will be produced. So let's convert the 6 moles to what? Mass. Remember that the molar mass of CO2 is C plus O2. That's 12 plus 16 times 2. 12 plus 22, which is 44. Right? Remember I've done it before. Right? So and then remember that number of moles goes to mass over molar mass as usual. And then mass equals to number of moles times molar mass. You get mass is not equals to what is the number of moles? 6. What is molar mass? 44. We have 6 times 44. 6 times 44. 264. So the mass of CO2 is what? 264 grams. That's option what? C. So you see how this thing is easy. This thing is easy, very, very easy. So let's take the 7th question from JAMB past question. Don't worry, go and solve, go and look for questions to solve. This 8th question, this 8th one is the toughest. Yeah. And that's why I reserved for question 8. And this is what? Yeah? I know, okay, it's not what I expected. Okay. I didn't want, well, I will snap 1 2 times. So yeah, that's it. Okay, yeah, it's different, yeah. I remember now. This is JAMB 1979, question 15. And the question says, how many grams of hydrogen bromide would exactly be required to react with 2 grams of propane. Give it that C is what? H is what? Means H. I got my backs are hurting me. Okay. 6.1 gram. Option C is what? 8.1 gram. Or they just 0.1. Option D 3.1. Usually 60.2. Okay, this is the last question. And it's the like toughest actually, because number one, there's no equation, and this thing requires a very sensitive reaction in organic chemistry. Alright. Now the first is to get the equation. Now there's something we know as addition. Yeah, addition reaction. It's peculiar to organic compounds. You get, and it happens in alkenes and alkynes. It's different from substitution. Now addition, 2 compounds come together, they add to form 1. You get, that's addition. So please, this question, if you don't understand how I got the equation, you have to go into organic chemistry. But I'm not teaching organic chemistry now, so I'll not be explaining that. Do you understand? So now the question is, how many grams of hydrogen bromide would exactly be required to react with 2 grams of propane? Propane, alkynes, the original formula is CnH2n-2. So prop is 3, C3H6 minus that's C3H4. That's propane. If you understand this organic chemistry, what you want to witness. So we have C3H4 plus hydrogen bromide. What do they give to us? Now this is called addition. Please take note that it requires, this is called an addendum. It requires 2 moles of an addendum to completely what's that stuff called? Okay, this is called hydrohalogenation. That's the addition of an hydrogen halide to a particular compound. You get, to convert it, to break a double bond and then convert it to a lower compound of the same number of carbon. You get, with a reduced bond of 1. In case you don't understand what I said, please, organic chemistry is what you read. You get. So it requires 2 moles of a particular addendum to completely saturate. That's the word, to saturate this guy. You get, because saturated compounds, they are either alkanes and cycloalkanes. While unsaturated, they are the rest, like alkenes, cycloalkanes, and the rest. So what I mean that for this guy to convert back to an alkene, we need 2 moles of this. You grab, that's it. And what happens is that, first of all, we have to, the goal is to convert this thing to, now the actual, what we get here is it's going to be 1, 2 dibromopane. You get, that's just what's going to come. So what we now have is C3H6PRO2, and that's what it is. So just because like that, that's what I'm going to get. So in other words, why do we know that we need to? That's because I know organic chemistry and I know reactions like this. I know how to tackle them using Markovnikov's rule. So you get, if you don't understand, please go to organic chemistry. But let's continue from stoichiometry here. We have gotten the equation. C3H is what? 6, PRO is 2. Now the action is the number of we are concerned with this guy and this guy. So 1 mole of this guy, we have 2 more of this. You get. Now they say 2 grams of this. So what is this thing now? This will find the same thing as C3 plus HHY. This is 12 times 3 plus 1 times 8. 12 times 3 is 36 plus 8. That's 44. Yeah, let me just give it to some mark. Any any small mistake we make, then we just square it. That's 44 years correct. So the molar mass of this guy is 44 grams per mole. So what is the number of moles? Is the mass here over 44? Right. We have the number of moles 0.045 or 46. Yes. So it means 0.046 give us x moles of what? Hydrogen bromide. So x equals to times 2, 0.046 times 2, 0.092 moles hydrogen bromide. So now that I've gotten this, remember the number of moles equals to what? Mass over molar mass. So and then mass is equals to number of moles. If you know this, we don't run like 1 billion times now. What's the number of moles here? 0.046. What is that the molar mass of hydrogen bromide? Hydrogen bromide is simply as hydrogen plus bromine, right? That's 1 plus 80, that's 81. Abi? That's 81. No, this is 92. That's 81. Okay. Wait, let's see something. Let's check. Something went wrong. See, I made a mistake. This is 𝗬𝗵𝗍𝗶𝗀. Are you getting? So let's start from here back. So need everything I've done now. You see why mistakes are not fixed. I know that I cannot get an answer that is not in the option. So since it's 𝗬𝗍𝗶, this is 12 times 3 plus 1 times 4. If I series 36 plus 4, that's 40. So it means number of moles of this guy now. Number of moles equals to what? 2 over 40. So divided by 40 is what? 0.05. So now that this one we have it 0.05. We have it x. So x equals to 0.05 times 2. 0.1 moles of hydrogen bromide. You get. Now that we've gotten the number of moles of hydrogen bromide, we can get the mass, right? So remember the number of moles goes to mass over molar mass. And then the mass of 𝗬𝗵𝗆 goes to the number of moles times the molar mass of 𝗬𝗵𝗆. Now 𝗬𝗵𝗆, the molar mass is simply as H plus 𝗵𝗆. 1 plus 80, that's 81. Abi? So we have, what's this thing here? 0.1 times 81. We have 8.1 grams of hydrogen bromide. That is why option C is correct. So guys, we have come to the end of this first part. We have talked about number of moles formulas. We have talked about mass relationship. We have talked about mass volume relationship, and we just solved 8 past questions on mass relationship and mass volume relationship, just for you to understand and see how it works in real life. So what I will encourage you to do is to go and attempt more questions. I've solved a lot. Go and solve more. So this will be the end of this video. In the next video, we are going to talk about the stoichiometry of solutions. We'll talk about the contribution of all those guys. We'll stay there. They are going to waste time. They're going to solve a lot of questions. And then for them, we'll not talk about acid-base titration, also dilution and all those stuff. Then talk about limiting and accessory agents. Then we are done with stoichiometry. Thank you for watching.